Good morning, students. So, in the last class, we discussed about that Lewis-Strauss structures and how to write the Lewis-Strauss structures upon learning how to satisfy the octet configuration, everything. Okay. So, the next one is why the Lewis dot concept is discarded. Why the other theories are introduced? What is the limitations of this Lewis concept? Okay. So, let's discuss. There are three limitations are there. Okay. So later I'll explain and simply mention them here. Limitations of Lewis concept. Okay. So the first limitation is, so student, this one is showing incomplete octet configuration on central metal atom. First one, incomplete octet configuration on central metal atom. First limitation. So later I will explain. Second one, extended octet rule. Next one is extended octet rule. So now extended, expanded. Okay. So third one is odd electron system. These are the three limitations of this Lewis concept. Okay, next. Another one is octet configuration on inertness of noble gas. Okay, next. Octet configuration doesn't explains or account for the shape of molecule. So these are the limitations. Understood? So students, here the first one is incomplete configuration on central metal atom. Next, expanded octet rule, odd electron system, octet configuration and inertness of a noble gas. Next, octet configuration doesn't explain shape of molecule. Okay, so we will discuss one by one. The first one is incomplete octet configuration on central metal atom. So students, the main thing you decided is what? So the main thing we need is what? After bonding, except hydrogen. Hydrogen satisfies two electron system, means doublet. Because hydrogen is here, the corresponding noble gas is helium. So that's why it satisfies two electron system. That is the postulate of Lewis concept. Okay, and another one is the next one, except that hydrogen. Remaining all the elements satisfy the 8 electron system because the corresponding noble gases are here are in the second period, third period, fourth period, fifth period. They are having 8 electron system in the outermost configuration, those noble gases. Means the main thing according to the Lewis concept is after bonding except hydrogen, each and every atom should satisfy 8 electron system. Understood? So now the incomplete octet configuration of the central metal atom. That cannot be explained by this. Which type of molecules? So I'll take the example for this. One is what NA of course satisfies LiCl. So students, lithium atomic number is 3, chlorine atomic number is 17. So if you write the electronic configuration, this is 1s2, 2s1, this is 1s2, 2s2, 2p6, 3s1, sorry, 3s2, 3p5. So here this is the valence shell, here this is the valence shell. Okay, of course we clearly know how many bonds are formed in between this lithium and chlorine means only one, because this is the first group element. The first group element, hydrogen, sodium, lithium, potassium, rubidium, they have the capacity to form only one bond. They are monovalent. Monovalent means their valence is only one. Okay, they have the capacity to bond with only one atom. Means only not only one atom, they form only one bond with the atoms. Okay, so here 2s1 means lithium is here. This is how we are representing the lithium along with the valence electron in the Lewis concept. Next, Cl atom is here. Outermost electrons are 5 plus 2, 7. So 1, 2, 3, 4, 5, 6 and 7. So students, here we know that one electron of lithium and another electron of chlorine. So they form bond here. Of course, no doubt, this lithium electron is towards this chlorine atom. Okay. So after that, this lithium satisfies 2 electrons and this chlorine satisfies 2, 4, 6, 8 electrons. Even though there is the main rule is what? So after bonding, except hydrogen, whether it is lithium, boron or anything, they should satisfy 8 electron system. Are you getting? But here, in this case, here this chlorine satisfying 8 electron system. This is correct. But this lithium cannot satisfy 8 electron system. It is satisfying only 2 electron system. Even though, okay, even though it is not having 8 electron system, this molecule is stable. So this Lewis concept fails to why these lithium, boron, beryllium, such type of compounds cannot show octet configuration. So even though they cannot exhibit octet, then also they are stable. Why? So this Lewis concept fails to explain the stability of or incomplete octet configuration of this type of molecules. This is one example. So another one I take BeCl2. No need Cl2 only, you may take BF3 also. Sorry, BeCl2, BF3, anything. Sorry, BF2. Okay, any one halogen. Or BH2 you take. No need to take the, you take just simply BH2. So students here, beryllium atomic number is 4, configuration is 1s2, 2s2. Hydrogen atomic number is 1, configuration is 1s2. Now, so the beryllium is here. 2 hydrogens are bonded. So the beryllium valence is 2. Hydrogen valence is 1. So students, including bonded electron, these hydrogens satisfies of course their respective configuration. But here, this beryllium satisfies 4 electron system instead of 8 electron system. But this is stable. This is a stable compound. But it is not satisfying 8 electron system. So again this Lewis concept fails to explain stability of this type of compounds. So another one, if we take the third example is BF3. Okay, so boron atomic number is 5, 1s2, 2s2, 2p1. This fluorine is 9, 1s2, 2s2, 2p5. So this is the valence electron, this is the valence electron. Okay, so boron and here, valence electrons is how much? 2 plus 1, 3. So fluorine is here. On fluorine, valence electrons are 7. 1, 2, 3, 4, 5, 6, 7. Next here, 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, 7. So now students, along with the bonded electron, I will simply round up these molecules. You are fluorine with the bonded electron 2, 4, 6, 8, 8, 8. It satisfies 8 electron system. But if you consider this boron along with the bonded electron of fluorine, it satisfies only 2, 4, 6 electron system. Means lithium, beryllium, boron. So this forms a stable compound. Lithium chloride is also stable, beryllium hydride is also stable, and boron fluoride is also, trifluoride is also stable. Even though they are not satisfying this 8 electron system. So this Lewis concept fails to explain why these molecules cannot exhibit 8 electron system. Even though they are not exhibiting 8 electron system, they are stable. Understood? So this is one drawback. This Lewis concept fails to explain stability. So students, these limitations are important for 3 marks. That's why I wrote here. They won't ask this examples. They simply ask this one. Why? When I write the limitations of Lewis constant. Okay? I'm just explaining these things with an example. Okay. So the next one is expanded octet group. Okay. So what is that expanded octet group? I'll take the example here. So one is the example 1, that is H2SO4. Okay. Students, here sulfur is there. Okay. Sulfur belongs to oxygen family. It has 6 valence electron. It has the capacity to form 6 bonds. So listen here. Oxygen is here, as I told you. It exhibits which type of oxidation state means? If it accepts 2 electron, it exhibits -2 oxidation state. So instead of accepting an electron, if it removes all the 6 electrons, it exhibits +6 oxidation state. Both oxygen family, okay, oxygen, sulfur, selenium, tellurium, polonium. So these exhibit -2 as well as +6 oxidation state. But this oxygen only stable in -2 oxidation state. It cannot exhibit +6 oxidation state. But these elements successfully explains +6 oxidation state. They cannot exhibit -2 oxidation state easily. Means the -2 oxidation state decreases along the group, +6 oxidation state stability increases along the group due to increase in size. Okay, remember that concept. So here, that means here sulfur is the central metal atom. Okay. Sulfur is the central metal atom here. It is bonded to, it should bonded with the 5, 6 electrons, so 6 bonds. So I write here simply, sulfur is there, 6 valence electrons are there. Okay? So each are doubly bonded with oxygen, I think one is here, another one is OH, another one is all the 6 atoms of this sulfur is bonded in this manner. double bond O, double bond O, OH, OH. Okay, so students, I simply write like this. Remember here. So here we have to check. So always, what is the main point? What is the concept here? So upon the central metal atom, after bonding, each and every atom should satisfy 8 electrons. So remember here, if I take hydrogen here, so consider these bonds as okay. Consider these bonds consists of 2 electrons because one bond is made up of 2 electrons. Bond pair. Here 1 electron, here 1 electron. Okay. So I'll just round up the molecule. Listen. 2, 4, 6, 8. 8 electrons will satisfy here. 2, 4, 6, 8. I didn't round up here. So 2, 4, 6, 8. Okay. Here 2, 4, 6, 8. So except sulfur, each oxygen satisfies 8 electron system. And now hydrogen. So hydrogen satisfies how many electrons? 2 electrons, including the bonded electron of this. So it satisfies 2 electrons. This is also satisfying 2 electrons. Okay. So these are satisfied with their valency and with their outlet configuration. The next comes is sulfur. So students, around sulfur, count. So here listen. These are the bonds formed by the sulfur atom. Okay, how many electrons are here? 2, 4, 6, 8, 10, 12. So instead of exhibiting 8 electron system, this sulfur is going to exhibit 12 electron system. This is somewhat expanded operator. It is more than 8. Okay, but this H2SO4 is stable. Are you getting? Why it is called as expanded octet rule? Because the sulfur atom should satisfy 8 electrons after bonding according to Lewis concept. But instead of 8 electron system, it is satisfying 12 electrons even though it is stable. Even though it is satisfying 12 electrons, then also this molecule is highly stable. And this Lewis concept, one of the limitations is it couldn't explain expanded octet rule. So another one molecule you may take, that is HNO3. Okay, directly I will write. So nitrogen is here with this type of electrons. Okay, 5 valence electrons are there. So I will directly write the bonds here. Double bond O, double bond O, OH. OH I will write like this. Students, remember here, this oxygen is there 2468, this oxygen 2468, this oxygen 2468. Hydrogen is 2, that is satisfied. So we need to check the central metal atom, that is nitrogen. So just round up the bonds around this nitrogen. Here 5 bonds are there. 5 bonds means each bond is made up of 2 electrons, means 10 electrons. This nitrogen, instead of exhibiting 8 electron system, after bonding is exhibiting 10 electron system, but that is stable. So this is also cannot be explained by this octet configuration or cannot explain by this Lewis concept. And the third one is SL6. Okay, of course sulfur is there. It is bonded to 6 fluorine atoms. Okay, so listen, each fluorine is singly bonded with this sulfur means here 7 valence electrons with 1 electron. And right here 1, 2, 3, 4, 5, 6. So it satisfies an 8 electron system. Similarly, each fluorine satisfies 8 electron system because they are simply bonded. But here around sulfur, how many bonds are there? 6 bonds are there. 1, 2, 3, 4, 5, 6 means that is 12 electron system. Understood? So this is all about what is it? Expanded octet group means behind that octet. Octet means 8, but these are more than 8. And this table fails to explain why these atoms are satisfactorily so stable even though they are having greater than 8 electron system. Okay, so this is one limitation, remember. And the third one is odd electron system. Third one is odd electron system. So what is this odd electron system? For example, you take NO and NO2 as an example. NO, that is stable. So nitrogen has valency 1, 2, 3, 4, 5. Okay. Next, oxygen has valency 6. 1, 2, 3, 4, 5, 6. Oxygen, nitrogen can form single bond, double bond and triple bond. This oxygen can only form single bond and double bond. Remember, 2 bonds, 3 bonds. Oxygen cannot form 3 bonds. So now, here what happens? They form double bond. N, double bond O means, so students, this electron forms one bond. This electron forms another bond. So then, upon this nitrogen, only 3 electrons are there. Upon this oxygen, 4 electrons are there. So students, remember here, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen satisfies 8 electron system. But this nitrogen, 2, 3, 4, 5, 6, 7. This satisfies 7 electron system. Why? So here they mention odd electron system. Means they are not having which type of configuration? Even configuration. They are having odd configuration here. This one is odd configuration. 7. Even though they have the 7 electron system, they are stable. This one is of course 8 electron, this one is 7 electron. Only nitrogen compound exhibit this type of, this is stable, but they have odd electron system. But that's why, so this Lewis concept only successfully explains the 8 electron system, cannot explain the 7 electron and below and above. Okay, so that's why, based on that reason, this is the one main reason why this theory is discarded. These three are the main reasons. So what I explained are structures before are highly stable. Okay, they are exhibiting in our daily life. Of course, they are existing in the nature. That means one which is existing in nature, that should be stable. Okay, so even though they are stable, with this type of electrons, one is incomplete configuration, one is expanded configuration, another one is odd electron system, even though they are stable. But this is not a Lewis concept. Understood? That's why this is one reason. Another one, if you check NO2. So NO2 means this nitrogen. Okay, forms NO2 black. N double bond O, single bond O. Here there is plus, here it is minus. Okay, or instead of that, you may write like this also. This is the structure. So students, upon nitrogen, These electrons are there. Other oxygen, 6 electrons are there. Here double bond is formed, means 2 electron of this nitrogen and 2 electron of oxygen forms double bond. Similarly, here also 2 electrons of this oxygen and 2 electrons of this nitrogen forms double bond. Here, if you count the configuration, it is 2, 4, 6, 8. Here 2, 4, 6, 8. But here 2, 4, 6, 8 in nitrogen system. These nitrogen atoms in this type of compounds, even NO is stable, NO is stable, but they are not satisfying 8 electron system. They are satisfying odd electron system. After bonding also, they are having odd electrons. Understood? So this is about the limitations of first degree conception. Next one is octet configuration of inertness of a noble gas. So inertness means, you know, this, what is it? This Lewis successfully explains. So each and every atom should satisfy noble gas configuration even after bonding an electron or by sharing an electron or by complete transfer of electron. But the main thing we know is what? These noble gases are inert in nature. That means inactive. They cannot be easily react with others due to their stable configuration. So students, at this case, what is happening? So listen, after bonding, so if anything I said, NaCl is formed, means which should be stable. It cannot be reacted with any other atom because they are satisfying noble gas configuration, means that configuration is highly stable. But when this NaCl is dissolved in water, it is dissociated as Na plus and Cl minus. Okay, if it is in water, it dissociates as Na plus and Cl minus. If they are inert, how can they react with the remaining? How can they dissociate into Na plus and Cl minus, even though they are satisfying noble gas configuration? Okay, so he only successfully explains the 8 electron system. He fails to explain why the 8 electron system is stable, why these noble gases are inert, why they are not readily react with any other atoms. The next one is octet configuration does not explain shape of molecule. So students, you know that if I take the carbon dioxide, this is linear in shape. If I take BF3, that is triangular in shape. Like this. Okay, that is triangular in shape. That we know today. Okay, after studying those theories, we came to know this is the structure of carbon dioxide, this is the structure of boron trifluoride. But this Lewis concept cannot explain the shape of the molecule. It only explains the number of bonds between them. Okay, whether this is single bond, double bond, triple bond. Only it explains that much. But this cannot explain, okay, the shape of the molecule. So these are all the limitations of Lewis concept. This complete octet configuration and central metal atom. Next, expanded octet group on central metal atom. Odd electron system on central metal atom. Octet configuration on inertness of the noble gas. Next, octet configuration does not explain shape of the molecule. Okay, so these are the drawbacks. Next, to overcome these drawbacks, the next theory is introduced. Okay, what is the theory? That is valence shell electron pair repulsion theory. Okay, so the students, next theory is valence shell That is called as VSEPR pairing. Means valence shell electron pair repulsion. Valence shell electron pair repulsion. Understand? So students, listen here. Now, here we are going to study about the repulsion theory. Okay? Listen. Two types of electron pairs are there, as I told you. For example, if I take H2O molecule, that is written as okay. So these electrons of hydrogen and electrons of oxygen together forms a bond. So these two are bond pairs, means electrons involved in formation of the bond. And these two other non-bonded electrons are lone pairs. Non-bonded electrons on the atom are called as lone pairs. Bonded electrons means the electrons involved in bonding are called as bond pairs. So here what happens means this how can we calculate this lone pair and bond pair? Based on this lone pair and bond pair, how the shape of the molecule is distinct. That is explained by this valence shell electron pair theory. And remember, as this is also an electron, these are also an electron. Okay, this lone pair is also an electron. These bond pairs are also an electron. Here I take like this. So this is also minus in charge. These are also minus in charge because both are electrons. Then if minus minus is there is a repulsion force. If they are together, same forces are there, they repulse like this. Understand? If they stay together like this is one bond pair, this is one lone. Okay? Sorry, this one is bond pair, this one is lone pair. They are like adjacent to each other. When because of minus minus charge, they repel like this. That is called as repulsion. Between what? Lone pair as well as lone pair, bond pair and bond pair, bond pair. Repulsions are there. Why the repulsion is there? Because there are electrons. Electrons are of negative charge. You know, unlike poles attract each other, like poles repel each other. Similarly, unlike charges, means different charges, plus and minus, they attract with each other. And like charges, means plus plus and minus minus, they repel each other. Understand? Okay. So now we are going to start with the postulates of this valence shell electron pair repulsion theory. Okay. The first postulate, I'll take postulates here. Very important for 3 marks. Postulates of all the theories. The first one. Okay. Electron pair in the valence shell repel each other as they are negatively charged. Okay, that is the first postulate. Okay, the electron plates occupies respective positions account for positions results in shape of a molecule. Okay, the electron pairs in the valence shell, okay, then occupies the respective position that results in the shape of the molecule. Means this theory, initially the drawback of the Lewis concept is it doesn't explain the shape of the molecule, but this valence shell electron pair repulsion theory explains the shape of the molecule. Okay, of course this is also having drawback, later I will explain that. These are the postulates. Okay. The repulsive interaction, the repulsive interaction between electron pairs are in the decreasing order. Okay, so here lone pair repulsion is greater than lone pair bond pair is greater than bond pair. So students here, if the what I am telling is, listen, if oxygen atom is there, if like this, two, okay, so this is bond pair, this is lone pair. Both these two are bond pair, these two are lone pair. So students, repulsion between this lone pair is more. Means in between these two electrons, the repulsion force is more. So in between this lone pair and bond pair, these two, the repulsion is somewhat less. In between these two, it is completely less. Okay, repulsion between these two, one. Repulsion between these two, this is 1, this is 2, this is 3. Okay, one is the lone pair repulsion because these two are the lone pairs. Second is lone pair bond pair. Third one is bond pair bond pair. According to this, one is greater than 2, greater than 3, like that. Okay, so I will explain the angle and also I will explain the shape. I will write the repulsion force and all. Just remember, this is the correct order of repulsion between the bond pairs, lone pairs. Okay, next. The fourth one postulate is the repulsion is maximum when angle is 90 degree and minimum when angle is 180 degree. Means repulsion is maximum when the angle is 180 degree and the repulsion is minimum when the angle is 180 degree. 90 degree means like this. So if the bond pairs are in this here, remember bond pairs are here, lone pairs are here like this, then here the repulsion is more. Next here, so bond pairs are here, this is the central metal atom, assume A. Lone pairs are here, then the repulsion is less because here the angle is 180 degree, here the angle is exactly 90 degree. So here the repulsion is maximum where the angle is 90 degree, minimum where angle is 180 degree. And the next one, students, the atom when the distance between when the distance between the electron pairs is maximum, then atom acquires minimum energy maximum stability. This is all about the postulates of valence shell electron pair repulsion theory. Means electron pair in the valence shell means last shell repel each other as they are negatively charged. As I told you, both bond pairs as well as lone pairs are negatively charged. That's why they get repelled. Next, the electron pair occupies the respective position results in the shape of the molecule. Means this theory successfully explains the shape of the molecule. Next, the repulsive interaction between electron pair and the nucleus similar means two electron pairs are there, one is lone pair, the other one is bond pair. The repulsion between them, lone pair repulsion is very high compared to lone pair and bond pair. Next, the repulsion is maximum when angle is 90 degree and minimum when the angle is 180 degree. Means while we are writing the shape of the molecule, if the orbitals are in the difference of 90 degree, okay, so then they are forming 90 degree angle means repulsion is more, 180 degree angle means repulsion is less. Next, when the distance between the electron pair is maximum, then the atom acquires a minimum energy and maximum stability. Okay, this is about the postulates. So in the tomorrow's class, we will discuss how the molecules are classified or shape of the molecule is decided by this valence shell electron pair repulsion theory. Thank you.